Problem one, we have a heat engine. You know, when I say heat engine, so we have a hot reservoir with T hat, and the engine has some quantity of Q hat added, and we have a released quantity of heat Q cold released out of the engine to the cold reservoir with T cold. And here we have the crank of the engine will do a quantity of work omega. First of all, we have a heat engine takes in 360 joule of energy from a hot reservoir. So the quantity is Q hat equals to 360 joule. And we have 25 joule of work in each cycle. So for each cycle, we have omega equals to 25 joule. First of all, we have to find the efficiency of the engine, and we have to find the energy expelled to the cold reservoir in each cycle. So we have to find Q cold. You know, for each cycle, a complete cycle, delta internal energy equals to 0. And according to the first law of thermodynamics, we have delta E equals to omega plus Q, or you can say Q minus omega. Okay? You know, the heat engine, we have a clockwise cycle. In general, we have a clockwise cycle. In this case, we have omega done by the gas must be positive. Okay? So, and Q equals to Q hot minus Q cold. We can say directly Q hot minus Q cold equals to or minus omega equals to 0, and Q hot equals to omega plus Q cold. The quantity added to the engine Q hot equals to omega plus the released quantity Q cold. So you have to know this relation. Now I want to find the efficiency. You know, the efficiency of a normal cycle equals to omega of the cycle divided by Q hat, and omega of the cycle minus omega. So we have omega equals to Q hat minus Q cold. So, or we can write directly the relation 1 minus Q cold divided by Q hot. Here, I don't know the value of Q cold. I have only Q hot. We cannot find the efficiency from this one. So you can use this one. So here you have the opportunity of you have two choices to calculate the efficiency from the work divided by Q hat, which is equal to 25 divided by 360 joule. You know the efficiency must be less than 1. In the case of here we have heat engine, so we have a clockwise engine. We calculate the value. It will be equals to 0.06. So 0.06. In this case, we have about 6% efficiency. Okay, normally it's a small value. It's a small value. Second, B, we have to find the energy expelled to the cold reservoir. It means we have to find Q cold. We can apply this relation, or you can apply this one. Okay, so we can say here Q cold as absolute value, be careful, equals to Q hat minus omega. Okay, so equals to Q hat 360 minus omega 25. We have 335 joule. When I take the absolute value, if we don't have absolute value, Q cold equals to minus 335 joule.